Okay, let's see. So, Mr. Max, is there a reason we did not finish section 1, sir? Max. How did you not finish section 1, but you started section 2? Okay, questions on number 1.
No.
Okay. Number 2.
Doing part A, right?
Yes. So number 2 should say f prime of x is square root of x sine 3 square root of x. Number 3.
Nope.
Number 4.
Yes.
Okay. Okay, so before we even try to apply the mean value theorem, what's the requirements for mean value theorem?
Continuous and differentiable.
Okay. So on this function, without even looking at the answer choices, where do we run into issues on this function? On the interval from 0 to 5.
At 1,
Why at 1?
because sine of 1 is 0.
Sine of 1 is 0. How did we come to that conclusion?
Or is it cosine of 1 is 0? It's cosine of 1. Well, at 0, then we have a problem.
So, first of all, cosine of 1 is definitely not 0. Gotta be careful.
Wait,
However, neither is sine. When is sine equal to 0, since we're dealing with sine in this case?
0.
Cosine of 0?
No, when is sine 0?
0,
So 0.
right?
Do you agree with Ivy? As everybody's scrambling to check their trig functions. You guys are killing me on this. Sine of 0 is 0, yes. So, but clearly on this problem 0 is not an issue because none of our intervals that they've given us on the solution choices involve 0. So do we have any other issues besides 0?
X squared minus 9.
How does that create an issue?
Well, I can't. Oh, well, I guess you can have 0 on the top, can you?
Can you have 0 on the numerator? Is that okay?
I think so.
So 0 in the numerator is just fine, yes. We have issues. Why do we have issues with the denominator being 0? What happens if the denominator is 0?
It's like
It's
undefined.
undefined.
Okay,
So therefore it's not continuous.
so we have to be careful. We have two different options for the denominator being 0. Do we remember what those two options are?
Isn't one a horizontal tangent line? Not horizontal, vertical.
So one option is a vertical tangent line. what's the other option? So it's possible you have a vertical tangent line or
0.
A hole.
there you go, Ivy. So you have, if your denominator is 0, you have the option of having a vertical tangent line or a hole. Clearly, nothing is going to cancel out on the top and bottom because you can factor the top, no big deal, but you can't factor the bottom. So nothing cancels out. So these would be vertical asymptotes. So you need to figure out when is the denominator 0. As Ivy's already mentioned, at 0. Is there anywhere else the denominator is 0 besides 0?
Isn't it like,
At pi.
yeah, pi?
Anywhere else?
2 pi?
Anywhere else?
3 pi?
Okay, let's generalize that then.
What does that mean?
So how could we give all of the solutions? Because clearly, as you figured out by now, it's going to go on and on forever and ever. How can we generalize where the denominator is equal to 0?
Well, but our interval is only to 5.
That's fine. We're going to then take that into account after we figure this out, because it may not always be true that it's from 0 to 5. So how can we generalize where the denominator is equal to 0?
Well, every time it increases by pi. Like I don't know.
Okay, so
Is it like a variable and then pi, like x pi,
I wouldn't say x pi. That would definitely not be what I would
a
say.
pi?
You could say a pi, yes. But you have to be specific about what is a at that point.
The number of, yeah, I don't know.
A would have to be a integer. Any integer
Oh,
value.
well, yeah.
So when an easy way of saying this would be any integer value of pi, aka 0 is an integer, so 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, etc. Or negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi. That would be what we call an integer value of pi. When you did it in trig class, you would have called it k pi. If you remember from trig. You don't have to call it that or anything like that. We're not looking for that. But we do need to realize that any integer value of pi will give me a 0 on the denominator. So in other words, those are all vertical asymptotes for this. So we can't have a vertical asymptote in our domain, or in our domain, because that would cause us to have a point of discontinuity, which means I cannot apply the mean value theorem, because if it's discontinuous, it's also not differentiable. So in looking at our intervals, do any of them contain a value of pi?
Pi.
I guess 3 does.
Why does 3? Because you're guessing, you said.
Well, because I know just normal pi by itself is 3.14. So, I know that's in that range, basically. And
Careful.
that's
In that
not in
domain.
any other range
Careful how you.
domain.
Yeah. So that is correct. If you look at 3, 1 to 4, pi is included in there because pi is approximately 3.14. So obviously 1 to 4 includes that. So 3 is out. What about 1 or 2? Do they include any multiple of pi?
I don't believe so.
We just went over pi is 3.14. So is 3.14 in anywhere from 1 to 3 or 4 to 5?
No.
The answer is no. Okay. And if you think about when you take your derivative of the function, so make sure it's differentiable, so that's the continuity part. So 1 and 2 work. When you take the derivative, you're going to get a brain fart, something on the top, and then sine squared on the bottom. So again, the only thing that's going to matter there is going to be your sine function, so it will be differentiable on those same values that it is continuous on, so 1 and 2 both work. Does that make sense of what I said?
Mm-hmm.
Number 5.
Sure.
What did you say, Megan?
No.
Number 6.
Oh, yeah.
Okay. So the first thing is we don't talk about really using EVT a whole lot because it's kind of basic, but they explain exactly what it is in the problem. So EVT requires an absolute is when you find your absolute maxes and mins. So we got to ask ourselves what's required for it to be in order for there to be an absolute max and absolute min.
Continuous.
So you have to be continuous. That is correct. So just like the IVT, because the IVT and the EVT kind of go together, they are both required. They both require continuity. So we have to have that to have maxes and mins. Otherwise, you can have infinite discontinuities. You can have all kinds of different stuff. So in other words, part of this question is, which interval is it continuous on? So again, we have to find those issues. Where do we have undefined points, breaks, gaps, infinite discontinuities, etc., etc.? So on this function, where do we run into issues? So at this function, where do I run into issues with continuity?
X equals 2.
Okay, just 2.
And -2.
2 and -2. Very good. Remember, we got to factor that bottom, x minus 2, x plus 2. So if we look at all the intervals except for one of them, all of them except one contain a value of either 2 or -2, except for C. So the answer has to be C. Make sense?
Yeah.
Mhm.
Okay. Number 7.
I missed it. I thought it was C because I thought EVT only dealt with like continuous continuity.
It does, but that function is continuous on the entire domain of the problem because it says the domain is 0 to infinity. The only issues you have with this function are at -1 for continuity. So think about it this way. In order to have a minimum value, you've got to have a minimum. Or to have a maximum, you've got to have a maximum. What does this function do as you move to the right?
It just grows.
It just keeps growing and growing and growing. So we would say if we had to give a value, the maximum value would be
Infinity.
infinity. However, that's not a thing we can actually say because infinity is just a representation. So this actually breaks the EVT, but it doesn't actually break the EVT. It's actually not valid to apply it because to have the EVT, we have to have a endpoint. So this does not have a bounded interval, which is the biggest problem.
Okay.
So it has to be a bounded interval. And think about all the questions we've always done. Remember, for like IVT, MVT, EVT, you always have 2 endpoints, A and B. All of them require you to have 2 specific endpoints, not infinity. Infinity does not count.
Okay.
Number 8.
Yeah.
Yeah, I need number 8 too.
Okay, so what's it tell us about the function?
Continuous.
Okay, what does it not tell us about the function?
It's differentiable.
It's differentiable.
So what can I not use?
MVT.
There you go. That's why. Now they did try to trick you. If it's like the AB problem I did yesterday, let me see. 0 to 4, 16, yeah. So they did try to trick you because you would think that f prime of c equals 4. You would think that from using the MVT. However, you can only use MVT if it's continuous, or if it's differentiable.
Yeah. That's what I did. Like I was like, oh, I can just solve for it, and obviously it did equal 4, but since it's not differentiable.
Yeah. So technically, all four of these answers are quote unquote true. The only problem is you can't apply B just because it doesn't tell you it's differentiable at any point, and there's no way to figure out if it is differentiable or not.
Will you explain what C was saying? Like, I didn't really get it.
So f of c is smaller than or equal to f of x for all of them. In other words, there's f of c is the least value of the function. So let's say -2 was the smallest value. If I plug in f of 1, that is less than all of the other values, all of x. So that's less than f of 0, f of 2, f of 3, f of 4.
Oh, okay, that makes sense.
Yeah, you've got to have the equal there because it is equal to the smallest point. And then same thing for d except for it's the biggest point. So that's how you'd write out a max or a min technically.
Okay.
Number 9. That one should have been easy for you guys. 10. Again, probably pretty easy. 11. 12. 'Okay. Moving on to part B then.
I didn't finish.
That's fine. We'll just do what we can. Number 1.
What is the correct answer?
A.
Okay, well then I did it wrong.
Okay, so let's make sure we have our definition. What's the definition of a point of inflection?
Where concavity changes?
Very good.
Wait. Wait, are we on the one with the absolute minimum? Oh, mine's on question 3. Never mind. Never mind, I got it.
So you were on question 3.
Oh, yeah.
Okay, so it's a not I didn't finish, it's a I barely started. There's a difference there.
I did a fourth of it.
You did 2 problems.
I did 3.
Well, if you were on number 3, I just assumed you hadn't done number 3. I'm sorry.
I had finished number 3.
Oh, my bad.
I have done a fourth of this section. 25%.
Okay, so I should put a 25% in for your grade then? Yeah, that sounds good. Because you sounded pretty confident about that 25%.
Point of view. Didn't think we'd get this far today, so.
You didn't think we'd get through 12 problems on IVT or MVT and stuff, really?
We've done it before. I don't know.
Yeah, we've never spent an entire day on 12 problems. Especially not like old problems. Like new problems, yes. Old problems of derivatives, no. You guys can do derivatives. I know you can. So do I need to go over A for anybody?
No.
B?
What is the answer?
D.
B or C?
D, as in dog.
Well, I didn't get that. Let me see.
Okay, so how do we determine if a critical point is a max or a min? So first off, before we even do that, let's define what is a critical point.
I'm pretty sure
First
the
derivative
derivative
equals
is 0.
0.
Okay. Berrigan, Mac, and Max, do we agree?
Where's
What was the
Tanner?
question?
They said a critical point is where the first derivative equals 0, if I'm not mistaken.
Yeah.
That's a critical value.
Yeah.
Max, do we agree with that? Okay. Unfortunately, all of you are wrong.
I literally knew you were going to say that, like I wasn't.
And by wrong, you're forgetting the part I told you would forget. So it's not just 0.
And
Or
then the
undefined.
endpoint?
or undefined. Don't forget your undefineds. So when we talk about doing critical points, we usually don't have endpoints. Um, Now, if you're talking about the maxes and mins, then yes, that's where you're thinking probably. When you're finding an absolute max and absolute min, you have to use the endpoints. But when we talk about having critical points, we typically don't call the endpoints those, although they, I guess, technically would be. Um, but yeah, it's the undefineds. So in this point, it doesn't really matter how they got them or where they're from or anything. It's just the fact that those are critical points. So at this point, if we have the second derivative, and clearly we are not going to take an antiderivative of all that, because that would not be very fun, how do we figure out if it's a max or a min?
If you plug it into the second derivative and like if it's positive, it's a minimum, I think. Doesn't
Okay.
it flip?
It does flip.
So if
Very
it's
good.
positive, it's a minimum,
Hmm.
and if it's negative, it's a max.
That's correct. Can anybody explain why that is true? Why is it backwards? Okay, so it comes down to the fact that what does it mean if your first or second derivative is negative?
Um, that your first derivative is decreasing?
Okay, that's fine. Your first derivative is decreasing. Yeah, that's true. Doesn't really help us here though, because we're talking about maxes and mins of the function, so we want to relate the second derivative to the function.
The second derivative, it's like the rate of the rate. I
That
don't
is
know if that's
that is correct. However, that doesn't help us on this type of problem. That would be like a rate in, rate out kind of question.
yeah.
So it's just a basic question. What does the second derivative tell us about the function?
It's concavity.
There we go. Concavity. So if it's concave, if it's negative, it is concave,
Down.
and if it's positive, it is.
Concave up.
So what does concave down look like?
An N,
And what does concave up look like?
a U. Are you on Twitch?
Yes.
Oh, I didn't know that.
You
I,
shaved your head.
um, I
He
shaved
did
it
that
last week. Yeah.
Um,
I don't think Berrigan was here that day.
Oh, that might be, yeah, maybe.
Yeah. Yeah. No, it was fully shaved, and it will be again when I have a reason to keep it fully shaved and maintain it. Right now, I don't have much of a reason to do that extra work. But if you look at on Twitch, you have if it's concave down, you have a max. If it's concave up, you have a min. That's why it's backwards, because based on the shape of the graph. So all you gotta do is plug that into your second derivative, and you will figure out if you get a positive or a negative, and that tells you if it's a max or a min. Apparently, both of these, when you plug them in, you get negative numbers. So you have two maximums.
Mhm.
I forget
Was that a
what the
calculator?
difference between a maxima and a maximum is.
Maximus, plural of maximum.
Oh, never mind. Sorry.
You're fine. Yeah, maxima and minima is just plural. And yes, that is a calculator-enabled question, Mr. Rick.
Okay.
Yeah, they're definitely not expecting you to plug in those numbers to like e to the sine x and stuff like that.
Okay, good.
Some of it they could have actually without a calculator, because what do you know about e to the sine x?
Beats me.
If you had to say something about the function e to the sine x, and we're talking about, we only care about positive or negative at this point. What do you know about e to the sine x? What kind of function is e to the sine x? We'll go there.
Exponential.
That is correct. It's an exponential function. What do we know about exponential functions?
They
A
grow
base.
exponentially.
Not guaranteed, but they are. A basic exponential function will grow exponentially. But if we're trying to talk about just the function overall, what do you know about that function? think about when you graph an exponential, a basic exponential function like 2 to the x or anything like that. What do you know about that function?
It's continuous.
It is continuous, that's fine, that works, that's true, but it's not going to help us here. What are we trying to check here? We're trying to check if the second derivative is if we're testing for maxes and mins, we're trying to see if the second derivative is
Positive or negative.
okay, so what do we care about? We only care about if these numbers are positive or negative because I'm multiplying them in this case. So what do I know about e to the sine x?
It's, I don't know.
It's always positive.
I was gonna guess that.
Why is e to the sine x always positive? So what happens if sine x is positive? What do you have? Again, if sine x is positive, what do you have?
E to a
A
positive number.
Okay, and that is?
positive second
Positive.
derivative.
Well, we're not looking, we can't analyze the inside yet, but we're just looking at just the front part. So you have a positive. If sine is positive, you have e to a positive number, which is positive. What happens if sine is negative?
It's 1 over e to whatever it is.
And that is a
Positive number.
positive number. And then the only other case you have to look at, what if sine of x is 0? What if it's 0? You get 1. So no matter which case you have for sine of x, that is always a positive value. Now this being an exponential function is fine. It doesn't grow exponentially because it will oscillate because sine of x oscillates, but it is an exponential function. At that point, we can't really analyze the inside very well because you don't know the values of sine and cosine and things like that. You would know if they were positive or negative. You just wouldn't know if they were, how big they were to do the subtraction and stuff like that. So that's where the issues would run in. You'd run into problems. So this is
mine
why.
the only one that just stopped working?
I believe so. What stopped working?
Oh, like it said that it couldn't connect to the class, so I had to like
That's weird.
restart everything.
Yeah. As far as I know.
Okay, my bad.
That's weird. Okay, number 3 should have been real easy to do, hopefully. The answer is D, Ivy. So how do we get a absolute max? Like, what do we have to do in order to find this?
You find the critical value points and then test the critical value points and the endpoints by plugging it into the original function. Whatever the highest number is like the result is the highest or the absolute maximum value.
That is correct. Good job. So you gotta make sure, don't forget that last part that she said there, so don't forget to plug in the endpoints. That is the part that everybody always forgets to do. So everybody's used to finding the max and min by taking the first derivative, doing a number line, et cetera, et cetera. However, in this case, we don't need the number line because we're not looking for what we call relative max or relative mins. We're looking for absolute. So you just check the values of those critical points and the endpoints and plug them all in. They're relatively ugly values, in my opinion, because you don't get a calculator, so you have to know what 6 to the third is. But not the end of the world. I guess you could factor out an x and then do it, which is probably what I would do. But still, not the nicest values. Number 4, pretty much the same way.
There's like 3 that are the exact same.
In a row, yeah.
Yeah, so it's 5. It's just sines and cosines. Is everybody comfortable on number 5 with setting the derivative equal to 0 and solving that resulting trig equation?
I'm not. I didn't I wouldn't get there, but I don't know if I would be.
Okay, so real quick, take the derivative there, Ivy.
X, well, negative x sine of x, plus cosine x minus cosine x. So those would cancel out, right?
Yeah, this one actually ends up
So
being easier.
oh, okay. So then that'd be easy because then you just have negative or x, negative x sine of x.
Yeah, I didn't realize that was the derivative until I actually looked at the answer. So that one's a lot easier of a trig function than I thought it was going to be like a different trig function, but no big deal. Okay, number 6. So how do we connect? Oh, excuse me. How do we connect f prime to f double prime? Because obviously they gave you the graph of the derivative and they're asking about concavity. So how do those two graphs relate?
If it's
Wouldn't it be
decreasing,
where this graph is decreasing?
it's concave down, right?
That's correct, very good, because that would mean remember the second derivative is just the derivative of the first derivative. So if you want concave down, that means you want a negative second derivative. So where the derivative of the graph you see there would be negative. So where it's decreasing, so very good job. Um, Looks like 7's the exact same thing. Except for they went concave up, okay. 8, the second derivative test cannot be. Oh, they give you all the derivatives, okay. Okay, so do we have any trouble with this one, those of us that got there?
Mm.
Everybody okay? Good, yes? Maybe?
Yeah.
Okay, number 9. Ooh, they give you graph of f double prime.
Yeah, I need 9. Mr. O'Donnell.
I'm thinking, hold on, sorry.
Oh, okay, sorry. I just didn't know if you heard me.
Yeah, no, you're fine. Okay, so clearly the answer has to be A or B.
Yeah.
Um, okay. So the reason it's going to be B, because the answer is B, is the fact that if this is the graph of the second derivative, we know that the first derivative is increasing.
Okay.
Okay.
Because it's positive.
Because the second derivative is positive, we know the first derivative is increasing. We also know that at pi over 16, it would be 0. Because it tells us that the first derivative has a critical point at pi over 16. Does that make sense?
Yeah.
So it was negative for some value in between 0 and 16, and then it will be positive for some value from pi over 16 to pi over 2. So in other words, your function was decreasing for a little bit from 0 to pi over 16, and then increasing the entire time from pi over 16 to pi over 2. That's why it's an absolute minimum. So, I mean, very basically, it could just be as a check mark graph because you don't really know what it looks like. It's obviously curved and all kinds of other things, but it very easily just could have been like that because it has to be decreasing for a little bit. Obviously, it's going to be curved. It's not going to be straight like that, but a general like little basic idea of what the graph would look like would be some sort of little decreasing part and then increasing. It'd be concave up the whole time. So it'd have, like I said, it would have some curvature and things like that. But the general basic idea of the graph, if you like zoomed very far out, would look something like a check mark like that. So that is definitely a difficult question choosing between A and B. It's a step up of a problem. Um, 10 should probably have been pretty.
I missed 10, but I wasn't thinking clearly. I did this one while we were watching a movie, so I wasn't in the full.
Not a problem. So let's just look at the graph, or let's just talk about it real quick. Where could it possibly be concave up? If this is the graph of the first derivative, where is it concave up?
Wherever this graph is increasing.
So your only answer choices could have been from anywhere from -6 to -2, as well as 2 to infinity. So you can throw out anything that doesn't include just those intervals. And then they want to know where f is decreasing. So what does it mean for f to be decreasing?
F prime is negative
So what does that mean on this graph?
below the x-axis.
Yep. So you just look at where it's both of those situations we just talked about. So below the x-axis, which is -7 to like -4.5 or whatever the crap that is, and then like 0.5 to whatever. So those aren't exact points. That's why they're not gonna. It's not a big deal if they're not exact. So you're just looking for the interval that contains both of those things, though. So clearly it can't be A because that is not concave up. If you look at B, that is correct answer. Can't be C because from -2 to 0 the function would be increasing, and it can't be D because that's where it would be concave down. So it has to be B. So this one is honestly easier probably to just get rid of the answer choices that aren't correct, and then leave the answer that is correct. Charts. Number 11.
Yeah, I knew this one.
Twice differentiable, accepted x equals 2. Okay. Where the derivatives do not exist. Which statement could be false? F has a relative maximum at x equals 1. That's definitely going to be a true statement because you have a first derivative being 0 and a second derivative being negative, so maximum, that's good. B, the function has a relative maximum at x equals 2. We have a whole lot going on at x equals 2 that we can't be sure of.
The minimum at 2 also.
Quite possibly. We're not 100. We can't be 100% sure because.
No, I'm just saying you said maximum, so I was like.
Oh, I'm sorry. Then yes, minimum. So that's definitely possible because the first derivative test could prove that we get a minimum. The second derivative test is inconclusive, but doesn't tell us anything about what we do or don't have. But that is definitely possible. Graph F has a point of inflection at x equals 3. It's possible. It's not guaranteed. Actually, it is guaranteed. I'm sorry. Because it's from 2 to 3. So we definitely have a point of inflection at x equals 3 because your second derivative goes from negative to positive at that point. And then D, the graph of f has a point of inflection at x equals 4. We just don't know that's true because it goes from positive to 0 to unknown. So that one is
Why is that
could
the
be false.
answer?
Because that could be false.
Oh, it could be false, not right?
Yeah.
Oh, I put the one that was right.
Oh, well, A, B, and
But
C are
now
all
that
correct.
I look at it, they're all right. Yep. Okay, that was, again, movie time.
You're fine.
Me and my family we're watching all the Marvel movies in like chronological order of the story.
Yeah, been there, done that. It's fun.
I'm really enjoying it.
Yeah, I'm running out of things to watch. I'm just starting to watch random things on Netflix at this point.
Yeah, we're doing the Marvels, and then next we're doing the Star Wars series,
Tiger
and then we're
King.
gonna do Harry Potter.
I'm refusing to watch Tiger King on principle alone
Why?
because it looks stupid.
It is.
That's why I'm refusing to watch it on principle.
But it'll keep your attention.
It definitely is something else, but I definitely would watch it, like hands down. Like you need to.
If I run out of other things
Also,
to watch, I'll watch it.
also the lady in it, I read this article the other day, Carol Baskin, whoever's watched it, she wrote a letter to like the local cat sanctuary here telling them like they're doing everything wrong. Which I thought was funny.
Zoo World?
No, the
No.
cat sanctuary.
Yeah, we have a big cat sanctuary.
They don't have lion or tigers, but they have like bobcats and stuff.
I didn't know that.
Oh yeah, let's finish up number 12 real quick. Number 12, so we have another graph problem, graph derivative, kind of continuous function, blah blah blah. Which statement is true? F has 3 relative, extreme, at 1 point of inflection. It's definitely not true. It would have a couple points of inflection at least. So 1, 2,
If we're looking at a
3,
F prime
4.
graph,
Yeah.
we find points of inflection how?
Well, what is a point of inflection?
It's where concavity changes.
Okay. And so it's where the second derivative changes sign. So if we're looking for that, the second derivative, which is the derivative of this, changes sign, aka where...
I thought there was like where it's a max or min,
Okay, but
or
where...
like
Maybe where
or
slope
curved
changes.
because your slopes
It's
change.
where the second derivative equals 0.
No, not where it equals 0. It could be 0 or undefined, just like
Oh.
before. So, but what was mentioned, just to make sure you heard that, it's where the slope changes sign of this graph. So if you look from -3 to -1, the slope is negative, but after -1, it's positive. That's a point of inflection. Even though the slope never hits 0, it is a point of inflection because the signs do change. So you got 1 there, 1 at 1, 1 at 2, and then 1 at like 3.5. So you get 1, 2, 3, 4. You do not have a point of inflection at 6. You got to be careful. 6 is not a point of inflection because the slope is negative and then still negative, even though you get an undefined point. Remember, your critical points are where it's equal 0 or undefined, hands down. But points of inflection are only where it actually changes sign. So
So,
go ahead.
oh, go ahead.
So the answer is B.
No, the answer ends up actually being D. So once
That
we
was
know,
my question. So I know like a relative extrema is where the graph equals 0, but like at 2 it wouldn't be a max or a min, but the graph still equals 0, so that's why it's a relative extrema
Oh,
still.
is that right?
so yes, at 2 you would not have a max or a min. That is correct.
But it's still a relative extrema.
No, it's not a relative extrema.
Okay, then how'd you get
Where did
4?
we get our 4?
Number 6, or at 6.
Oh,
What does the derivative
I
do?
would not think that. I mean,
For
I guess.
remember, you have to remember it's where your first derivative is 0 or undefined. You need to find
Isn't
all of those
undefined
points.
a -1 too?
It is. But at that point, when we do our first derivative test, it goes from negative to negative.
Okay.
So that does not fill the criteria of a max or a min, just like at 2. At 2, it's 0, but as you already mentioned, it's positive to positive. So that creates what we call a false max or a min, a false extrema. Same thing at -1. While we do have 0 and undefines, we don't have a change in sign of the first derivative. So that's why we don't have this. So you got to evaluate all the zeros and all the undefined. So your critical points would be -1, 0, 2, I guess 3.5, 5, and 6. And you got to ask yourself, since we have the first derivative, we can do the first derivative test, and you could create like a number line, however you want to do it, and that's how you get those. Does that make sense, hopefully?
Yeah.
Okay. And so that's why the answer is D, not B. So just putting those together, you gotta be careful on the relative extrema part. Any other questions on that one? Like I said, that one's it's a tricky question. You gotta be very careful on. Okay. Then we are done for the day. Please make sure you do your C part and your free response, because it shouldn't, I'm assuming it won't take us the entire class to do C. It should only take us a little bit of it.
Sounds good.
Okay, you guys have a good rest of your day. I'll see you tomorrow.
All right.
Bye.
Bye.